$10,577, a price tag no one expected for this level of engineering. Tesla's Model 2 has just flipped the entire automotive world upside down. And it is not only because of how affordable it is. This car carries some completely unbelievable technology inside it. Technology that feels wild. Technology that feels almost unreal. So different from what people were told before. So, are you prepared for what comes next? Because the latest leaked testing information has revealed an experiment involving 3 brand new features inside this model. A nearly unbreakable polycarbonate front window, a thermal loop frame that changes the way cabin comfort works, and a weight-responsive floor plate that adjusts performance and safety instantly. All of these together have crushed expectations and created a ripple effect across the United States automotive industry. If you are tired of hearing the same repeated car news, then stay here because we added new details, new updates, and fresh analysis you will not want to miss. And let us help this channel reach 2,000 subscribers by simply subscribing. Let us go forward. First, how does the polycarbonate front window bring a structural improvement that American drivers never expected in a $10,577 electric vehicle? People driving in California, Texas, Florida, and New York face debris, impacts, and extreme temperature swings every day. Traditional laminated glass hits its limits fast, collecting tiny cracks and breaking under stress. The Tesla Model 2 introduces something completely unexpected. A polycarbonate front window that operates on a different structural level. So how does a polycarbonate front window engineered with multi-layer compression and a thermal protective coating change impact strength, temperature stability, and long-term cost for a $10,577 electric vehicle? Tesla replaced normal glass with a 0.27 to 0.33 inch multi-layer polycarbonate laminate. 3 layers working together. A flexible outer layer that spreads impact force across the whole surface. A ultraviolet stabilized structural core that keeps stiffness without becoming brittle. And a heat-reflective inner layer that cuts cabin thermal load before the air conditioning even turns on. This material bends under force instead of braking, working with the driver instead of against them. Here is the problem almost nobody discusses. Standard laminated glass forms small cracks after about 80 to 120 heat-cold cycles every year. That is simply one summer to winter cycle in most American climates. Polycarbonate keeps its strength for over 500 cycles, solving sun-driven expansion in Texas and Florida, freeze and thaw contraction in New York, and high debris exposure along California's Interstate 5. When small stones hit normal glass at 55 miles per hour, the glass cracks. When they hit polycarbonate's flexible surface, they bounce away. Different result, different material behavior. The performance difference is huge. Impact resistance increases by 160 times when compared to tempered glass, absorbing around 150 to 180 foot-pounds of force without failing. Flex deflection tolerance runs 0.08 to 0.09 inches under high-speed impact, which is enough movement to release energy without harming visibility or the window seal. Weight drops by 6 to 8 pounds, lowering front-end inertia and improving city efficiency by about 2.9%, which adds up over 12,000 miles each year. Solar load reduction lowers cabin temperatures by around 14 degrees Fahrenheit to 20 degrees Fahrenheit, cutting air conditioning usage by 9 to 12%. This is not comfort tuning. This is thermal control built into the structure. Controlled debris testing shows a dramatic advantage, proving that at 55 miles per hour, the polycarbonate window avoids cracking in 87 to 92% of tests, beating normal laminated glass easily. Long-term sunlight exposure testing in southern climates slowed the formation of ultraviolet haze by 30% when compared to untreated polycarbonate. Freeze and thaw testing over 1,000 cycles showed 0 signs of layer separation. These results are not science fiction. These are certification-level measurements. What shocked the United States market is this. Over the past 12 months, the insurance industry recorded more than 3.8 million glass-related insurance claims, with each laminated windshield replacement costing between $350 and $480. The new composite window removes 70 to 80% of common brake scenarios, shaking up insurance calculations across the country. Fleet operators in California and Florida reported that polycarbonate windows reduced downtime from small debris incidents by around 40%. No one expected such results from a low-cost electric vehicle. Heat-resistant performance also lowered cabin temperatures by 14 to 20 degrees, surprising air conditioning analysts who believed such results could only appear in luxury electric vehicles above $30,000. Material experts pointed out that polycarbonate of this thickness and clarity has never before been mass-produced for a vehicle costing less than $2,000 in material. This shift caused unexpected jumps in supplier demand projections. Senior transportation groups in Texas and New York noted the lower replacement cost as a major affordability breakthrough, bringing the Model 2 into discussions at state transportation committees, an unusual reaction for an entry-level electric car. Internal insurance models suggest that the Model 2's window design may cut small impact claims by 25 to 30% nationwide. That is true category disruption. For seniors with fixed income, this removes a repeating $480 replacement cost that damages budgets every 18 to 24 months. Lower heat load improves comfort for older passengers and reduces energy cost per drive. It is the kind of improvement that lowers stress, reduces upkeep costs, and keeps day-to-day driving comfortable for older drivers who need predictable expenses. If polycarbonate can survive more than 500 temperature cycles and deflect 55 mph debris impacts in a $10,577 vehicle, why is the rest of the automotive world still using glass that fails after 80 cycles? Write polycarbonate in the comments if you are tired of paying for windows that are not designed to last. But material innovation on the window is only the beginning. Tesla built temperature management directly into the vehicle's structural body with constant heat control without extra cost or weight. What is this innovation? Let us move forward. Second, how does the thermal loop frame provide constant heat management without increasing price or weight? Heat and battery wear are the biggest performance destroyers for low-cost electric vehicles. Many affordable electric vehicles struggle with uneven cabin temperatures, overworking the air conditioning system, and faster battery damage. The Tesla Model 2 reverses this problem with a chassis-level cooling strategy. So how does embedding coolant channels in the A-pillars, rocker beams, and floor crossmembers stabilize temperature better than ordinary radiators used in vehicles far more expensive? Tesla carved coolant microchannels directly into the structural frame during the metal extrusion process. The A-pillars that hold the front window, the rocker beams under the doors, the cross members beneath the floor, all of them circulate coolant. A single low-power pump keeps 1.9 to 2.4 liters of coolant moving every minute, spreading heat removal across large surface areas that previously did nothing. This does not add cooling parts. It transforms the frame into a giant passive radiator. The performance improvement is immediate. Heat removal improves by 22 to 28% when compared to regular isolated radiator systems. Cabin cool down from 120 degrees Fahrenheit to 76 degrees Fahrenheit becomes faster by 55 seconds. This matters when you sit in a Texas parking lot at 2 in the afternoon. Winter warm-up energy use drops by 9 to 12%, which matters when New York cold drains your battery before you even leave the driveway. Battery temperature variation stabilizes within 3 degrees Fahrenheit, improving long-term battery cell health by 7 to 11%. That means years of additional battery life before the battery capacity falls below useful levels. Here is how the system functions. The A-pillar and rocker beams behave like passive radiators, releasing heat into passing air without using fans or extra pumping power. Microchannel circulation prevents the formation of hot spots. No single area of the battery overheats while another remains cold. Cabin sensors adjust coolant temperature instead of forcing high-power air conditioning cycles that consume range. The car regulates its temperature through its structure rather than relying heavily on electronics. In terms of cost and weight, Tesla removed one secondary radiator and one coolant reservoir. Total weight savings reach 11 to 14 pounds. Material cost remains nearly the same because producing channels during extrusion adds almost no expense. You get temperature stability equal to luxury electric vehicles that use expensive $1,800 active radiator systems. The difference is Tesla achieves similar performance using frame geometry instead of costly hardware. In real-world driving, lower air conditioning load results in lower electricity bills, which seniors on fixed budgets feel immediately. Reduced heat shock improves comfort for older drivers sensitive to quick temperature changes who cannot tolerate swinging from 90 degrees Fahrenheit to 70 degrees Fahrenheit repeatedly. Longer battery lifespan means fewer expensive battery replacements over 8 to 12 years, eliminating the biggest ownership fear for budget electric vehicle buyers. The United States market was stunned to see distributed heat removal, a method used mostly in aerospace and refrigerated freight systems, appear inside a $10,577 electric vehicle. No automaker had attempted frame-integrated cooling at this price. Battery aging projections improved by 11%, shifting ownership cost calculations for older drivers. Climate laboratories in Arizona and Florida recorded 12% lower air conditioning load at 80 miles per hour, beating electric vehicles priced above $40,000. The United States Department of Energy noted that structural coolant pathways reduce the need for extra radiators, possibly changing manufacturing methods for low-cost electric vehicles. Cold weather tests in New York revealed quicker winter warm-up, earning the Model 2 recognition as a senior-friendly winter electric vehicle, the first ever at this price. Stable cabin temperature and reduced battery strain create calmer and safer everyday driving for older passengers across extreme weather conditions. No more guessing whether your battery will hold through a Phoenix summer or a Minneapolis winter. The vehicle manages itself. But temperature stability only matters if the structure underneath can handle real-world stress without sending every road vibration into the cabin. Tesla did not stop with cooling the frame. They created a floor that responds to weight dynamically, reducing joint impact and increasing balance without electronic systems or added cost. That is why the weight-responsive floor plate exists. Let us continue. Third, how does the weight-adaptive floor plate lower joint impact and improve balance without adding electronics or cost? Entering and exiting a vehicle creates some of the highest physical forces that older drivers experience daily. Most vehicles ignore this issue entirely. The Tesla Model 2 takes a new approach with a floor that adjusts naturally and without maintenance, offering real-world safety and comfort. So how does a multi-zone composite floor distribute weight based on the passenger's body mass while remaining totally passive? Tesla created a 3-zone adaptive floor with low, medium, and high force areas. These zones support weight categories from about 120 to 160 pounds, 160 to 220 pounds, and 220 to 260 pounds. Micro-flex channels inside the panel direct pressure to reduce stress on knees and hips without harming stability. On a standard car floor, peak entry forces reach 1.6 to 1.9 times a person's body weight. With the adaptive floor, a 160-pound passenger who would normally feel 272 pounds of force now experiences around 212 pounds. A 200-pound passenger facing 340 pounds of force now experiences about 265 pounds. The system uses 3 coordinated layers. A honeycomb composite that flexes in certain directions to absorb force. An elastic reinforcement layer that spreads vertical pressure sideways. And a stiff central spine that stops the floor from bending too much. Tesla adjusted the density of each layer so that the floor behaves predictably for all weight levels. After older test drivers reported slipping concerns, Elon Musk personally approved a final adjustment, replacing foam padding with a directional rigid composite that improved stability on wet floors by 14 to 19%. Practical benefits are obvious. Roughly 300 to 800 fewer micro-stress events every day on joints. 11 to 17% more energy absorption during sideways impacts because of the shear motion inside the floor. Orthopedic experts were shocked that a sub-$11,000 electric vehicle could reduce peak entry force by 18 to 24%, something previously seen only in high-end ergonomic platforms. Insurance groups in New York and California expect fewer low-speed entry and exit injury claims. Senior advocacy groups in Florida confirmed reduced slipping risk for wet footwear. Manufacturing analysts noted that no vehicle below $30,000 had ever used multi-zone composite weight tuning before, forcing new thinking about low-cost vehicle design. For older drivers entering and leaving a car 4 to 6 times every day, this floor system reduces long-term joint wear that limits mobility. Fewer micro-stress events mean a longer ability to drive without support, extending independence for years. If lowering peak joint stress by 18 to 24% every time someone steps into or out of a vehicle can prevent injuries and extend mobility for seniors, then why has no other automaker under $30,000 even attempted this? Write, I like, in the comments if you think designing for real human bodies rather than just printed specifications is what defines real innovation. 3 major technologies, one $10,577 electric vehicle, and every single one changes what Americans should expect from affordable cars. No other vehicle under $30,000 provides this amount of engineering, comfort, and daily usefulness. Seniors, everyday commuters, and budget-aware drivers now have a car that does much more than move them from one place to another. It actively makes every trip safer, smoother, and smarter. If this surprised you as much as it surprised the United States market, hit the subscribe button and turn on notifications. Join the 1,500 people already watching the future of Tesla development because this is only the start. Share your thoughts below and tell us which breakthrough amazed you the most. The Tesla Model 2 did not just launch. It shook the entire automotive world. And now it is shaking your expectations too.